Imagine a world teeming with the power of life, where ancient rivers cut their way through great rivers and torrents that transformed the land into a time of great distress. This is not Earth, but Mars, a planet that has captured human imagination for centuries. In 2020, when many space probes from around the world will land on Mars, the question of whether or not to live on the red planet will be raised. Among these missions, NASA's Mars 2020 stood as a symbol of hope in the quest to uncover the mysteries of Mars. What if we could find good evidence that life existed on this distant planet? What if the secrets of the ancient Martian megaflood could unlock the door to a deeper understanding of life's origins in the cosmos? As we delve into the latest findings from NASA's Mars missions, including the groundbreaking discoveries made by the Curiosity rover and the eagerly anticipated Mars 2020 mission, we will explore the tantalizing evidence that suggests Mars was once a planet rich in water and potentially even life. The key moments in this journey will include the revelation of a megaflood that occurred 4 billion years ago, the discovery of sedimentary layers that hint at ancient lakes and rivers, and the ongoing quest to find signs of life through the analysis of Martian rock samples. In 2020, space probes from various nations were en route to Mars, each with the mission to carry out a wide range of measurements and investigations. Among these, NASA's Mars 2020 mission garnered significant attention due to its ambitious goal, to uncover whether life currently exists or could have ever existed on Mars. As the world awaits new discoveries, reviewing data from older missions, especially the Curiosity rover, has yielded interesting insights. One of the most recognizable features of the Earth is the sign of a great flood that occurred on Mars about 4 billion years ago, which greatly increased the life of the Red Planet. Launched in 2011 as part of NASA's Mars Science Laboratory (MSL) mission, the Curiosity rover will land on Mars in the summer of 2012. When it returns to Earth, it will see the humans have a neutral view of the Martian landscape. Although intended for a shorter mission duration, Curiosity continues to operate and conduct important scientific research. The rover, along with 10 different instruments, will measure the weather, radiation and geochemical conditions on Mars. His ability to extract and analyze rock samples became a key driver in the discovery of the world's building blocks. The main focus of the Curiosity mission is to analyze sediment samples to determine if water, in any form, once existed on the surface of Mars. Curiosity's probe has focused on Gale Crater, a large impact area about 100 miles across. From the crater's center rises Aeolus Mons, also known as Mount Sharp, a 4-mile-high mountain that sits on the rim of the crater. Scientists believe that hundreds of different sedimentary layers have been deposited in the crater and Mount Sharp, providing a unique opportunity to study the evolution of Mars over a period of up to 4 billion years. The origin of these layers has been hotly debated, with theories suggesting that they were formed by volcanic eruptions, or that the crater was a frozen lake. Curiosity's choice of Gale Crater as a research site was strategic because analyzing these layers could provide new insights into the history of Mars, including the possibility of a major flood event. Early in the mission, Curiosity's sediment data revealed that Gale Crater was partially filled with water. The sediments show the presence of flowing rivers and water bodies. The discovery of clay minerals in these fossils proved that there was liquid water in the past on Mars, as these minerals only occur in the presence of water. In addition, hydrosulfates were identified, confirming the presence of water. Measurements of the Martian atmosphere and the planet's radiation have helped paint a picture of Mars' origins, suggesting that the planet's geological processes and atmospheric conditions allowed it to form. Water on the surface is an essential requirement for life on Earth. The discovery of water on Mars has led to speculation about the planet's ability to support life. But how did these rivers and waters interact with the Martian landscape? The Curiosity probe will answer this question by analyzing several sediment samples. One of the most famous discoveries is the sign of volcanic sediments in Gale Crater. These deposits show that water flowed through the crater at incredible speeds, reaching up to 30 feet per second. It's hard to fathom the size of these deposits, some of which are more than 300 feet apart and up to 30 feet high. Similar deposits on Earth are often formed from large ice masses, suggesting a similar process on Mars. It is believed that the cause of the massive melting of the ice on Mars was the impact of another meteorite, which could have produced enough heat to melt a large amount of ice. If this theory holds, it would indicate the second major meteorite impact on Mars after the first one that was responsible for the formation of the Gale crater. The heat from the second impact melted the ice and released large amounts of carbon dioxide and methane into the Martian atmosphere. As the ice turned into water, some of it melted and added water vapor to the atmosphere, creating a short, wet period of wet weather on Mars. This period of warm and humid weather will have a profound effect on Mars. The exact length of this period is uncertain, but it is likely that it was a long enough period to cause a major planetary shift. Evidence from other regions of Mars indicates that rain spread and filled rivers and lakes all over the planet. In such an environment, conditions are favorable for the emergence of microbial life. The water, the high temperature and the thick, airy atmosphere could not provide the nutrients necessary for life to begin. Despite these positive findings, curiosity is not ready to see life directly. That work will facilitate future missions, particularly NASA's Mars 2020 mission, which will also include the Perseverance rover. Launched in July 2020 and scheduled to land on Mars in February 2021, Perseverance is designed to take the search for life on Mars to the next level. Armed with sophisticated equipment, the patient collects rock samples that may contain signs of past life. However, due to severe contamination from Earth's equipment, the researchers decided to bring these samples back to Earth for detailed analysis. This would require an unprecedented mission to launch a space probe, rock from Mars to retrieve samples and return them to Earth. According to realistic timelines, these samples might not arrive on Earth until 2036. Until then, the scientific community and the public alike would have to wait, hoping that further investigations would yield even more clues about the possibility of life on Mars. The discovery of a megaflood on Mars, triggered by a meteor impact 4 billion years ago, has already provided compelling evidence that the red planet may have once supported life. The prospect of finding even the smallest traces of past life on Mars is tantalizing, and such a discovery would be a monumental achievement in the history of space exploration. The idea of extraterrestrial life has fascinated humanity for ages, and while bacterial life might not be what most people envision when they think of aliens, its discovery on Mars would still be groundbreaking. This raises the question, could Mars host more complex forms of life? And if so, what are these life forms like? As we continue to explore the red planet, each new discovery brings us closer to answering these profound questions. At this point we can only speculate, but the possibility of life on Mars is both exciting and real. The future of Mars exploration promises an exciting journey full of potential for some groundbreaking discoveries that will change our understanding of life beyond Earth.